This is the first video update for the 8-bit computer that I am building. In this video we're going to take a look at the current hardware setup and how to program the ROM chip. So the first thing here, this is the main board. Right here we've got the socket for the Z-80 processor itself. Over here we have the socket for the 32 kilobyte ROM chip. Here the 32 kilobyte static RAM chip. We have two peripheral interface devices here. Here we have the clock setup, which is a 4 megahertz crystal, as well as a hex inverter. This is a 3-to-8 decoder for memory decoding. This is a reset circuit, and this is an AND gate, which is used for part of the memory decoding. Over here we have a 20x4 LCD screen, which is going to be used as the screen for our device. And over here is the ROM programming board, which I'm going to show you right now. So ignore this part. This was a failed design, mostly because the chips that translated the binary data into the 7-segment data were not functional. But right here we have some address dip switches as well as some data dip switches. And here is the ROM chip. I have a quarter here as kind of a little heat sink, and the set button for our data. So as you can see over here, here is our power supply. We have 5 volts going in and 220 milliamps of current. So the first thing we're going to want to do is take a look at our ROM source code over here, which is on the computer. So we've got a few pages of ROM source here. So we're going to start with the print subroutine up here, which starts at address 7000, and the first byte is 3E. So we're going to come back over to the ROM board, and in the address dip switches we're going to start with 7000, and under data we are going to put in 3E, and then we are going to hit the button. Now when you hit the button, you can see up at the current that the current jumps by about 30 milliamps, which is the active current for when this device, the ROM chip, is executing a write. So we're going to go back down here to the switch. We're going to increase the address by 1, head back over. The second byte is 04. So we are going to type into the switches 04, and then hit the button, and you should be able to see another 30 milliamp increase in the current. So you have to do this for all of the bytes, and so far I've programmed about 300 bytes into the monitor source code, which after another 100 bytes or so will give me enough source code to be able to write to the device using a keyboard. So that's enough for this video. Check back later for the completed computer. Thanks for watching.